Welcome to the first lecture on Python. And in this introductory lecture, we're going to explore the basics, get set up with the environment, and then just get some simple programs running, be able to put some data into the program, get data out of the program. We'll explore ways to store data in variables, a concept that's quite fundamental to programming, and be able to use those variables, be able to assign values to them, to be able to update them as we go, and retrieve information from them. So that's all to come. As seen here, that's exactly what we're going to do. Start with an introduction, and then explore input and output, or sometimes you see I/O, that's just another acronym for input/output. Very common, I should say. That's the common archetype of the majority of programs out there. We input data, and then the program will do something with that data, and then it will output a result to us. A simple example might be using Amazon, for example. We search up a product, we type something into the search bar, we then get a result back, don't we? So the program will process what we type in and then give something back. So that we see that all over the place, and we'll constantly see that output. Types, like I said, yeah, that's inherited from older languages. We'll explore some differences between Python and some of the more traditional, strongly typed languages. We'll explore the difference in how they use types, how Python can reassign values of different types to a memory space. Explore that. Have a look at how we use variables and assigning values to those variables. Great. So with that established, we're going to jump in and have a look at the programming language that enables computers, or can enable computers, to be able to do just that, to process tasks, to calculate sums, to process inputs, to give outputs. So Python, not the snake Python, but the Python programming language. Okay, and here's a little statement from the founder, the founding creator of Python, the programming language. He described it, Guido van Roysum, Dutch programmer. We can see a little bit more about him soon. He describes Python as a high-level programming language. Its core design philosophy is all about code readability. That's a concept that we will come back to. And a syntax, again, that's important, isn't it? All languages, natural or programming, have a syntax, a defined set of rules. Grammar, you could say, we're used to that in the English language, to construct sentences. Programming languages have a form of syntax that enables them to construct their statements. Okay? Code readability and syntax, which allows programmers to express concepts being ideas, just ideas of things that we build a sort of a mental idea about. You might have had an idea about a computer as a concept. Okay, concept, we can explore those, what programming concepts are, in as fewer lines of code as possible, essentially is what we're saying there. We're trying to do what we need to with less code. We're trying to be efficient, code efficiency. Okay, so that's the ethos behind Python, indeed, which is common amongst all the creators of languages. They're often developed as a response to perceived problems elsewhere. So Python would have come out of, let's say, perceived lack of code readability. I don't know if you've ever had a go at some languages like Java or C# or C++. They do take a little bit of decoding. They're not as easy to understand at first glance. So that's often why Java and all these other languages are developed to try and address, in their eyes, some of the issues with some of these other languages. Okay, and syntax. So let's move on. Let's read a little bit more about Guido, who he is. Smiling, wearing a Google shirt, a conference probably, or some sort of event. Guido van Roysum, one of the key names. If you're into the podcast scene, you may have seen him on some of these podcasts. Tech Lead or Lex Friedman, he's been on those podcasts. possibly even Joe Rogan. I have to have a look at that. But I've definitely seen him on Lex Friedman, so it's worth watching. And he named it not after the snake, but after the UK comedy series. He's a Dutch programmer, grew up in Holland, but based it on, he really took a liking to Monty Python. It might be before your time, it might get lost on you. Has anybody seen Monty Python or heard of it?
Oh yeah, I've seen clips.
Oh, you've seen clips of it? Okay, so you have some way to relate to it. Okay, yeah, so John Cleese, Eric Idle, some other older comedians that were in that. Anyway, he took a liking to it and named the language after Python. There's also other references to the show, like Eric Idle. IDE stands for Integrated Development Environments, and one of the first Python IDEs was idle, with the L in it. So it's just a play on the word. But anyway, it's developing environment software essentially that's used to develop code. So the timeline that we have here is that one of the earliest versions of Python was released in the early 90s, which was technically before the release of Java, even though Java was being developed. That was in the mid-90s with James Gosling. So it would have been off the back of C++ and C. Those were the big languages at the time, until the 80s. So that's when Python first came up. It was radically different to C and C++, very strongly typed. And then later, the developments of it, 2000s, turn of the millennium, saw Python 2. And then what we're currently on, I think we're currently on Python, 3.8, I think, is the kind of last core release, last stable release, but I think Python 3.11 is one of the most recent that we're sort of dealing with now in 2023. But anyway, the most recent version of Python, Python 3, some programming languages actually coded in, some applications coded into them that they want higher than 3.8. So indeed, if you're installing it for the first time, you wouldn't have that issue. But anyway, Python 3 is the latest version that we're working with. And as I say, it did come out a long time ago, it's worth saying, and it did certainly have its applications. But more recently, data science and AI, if you're into those topics, they are using Python very heavily. I teach a lot of machine learning in Python, has a lot of convenient APIs, scikit-learn. It's got other libraries, NumPy, Pandas, Matplotlib, etc. Very, very convenient for doing machine learning, data science. And it was also taught in schools. Some of you may well have done that and learned it. Did anybody look at Python?
Yeah.
School? Yeah, so you did a little bit. Khalifa, did you? Yeah, a little bit as well. Okay, so you have a little bit of familiarity. I think it's getting a lot of favour because it is one of the languages that is closer to natural English. You can write coding statements like you would speak or write English. It's let's say very easy to pick up, a lot of people are saying. So definitely, if you're new to coding, probably the best place to start. Per the statement, really, the idea is to make it readable. That's exactly what I was just saying. The easier it is to read, the easier it is to understand. Syntax plays a part there as well. All the colons and brackets and commas and starter statements, capital letters, lowercase letters, all of that again can just be confusing when you're starting out. So having an easy way to get started with a program definitely builds confidence and scaffolds your journey as a programmer. So just a little bit more on the design philosophy, just to kind of give you the background context to Python. Guido says, beautiful is better than ugly. Well, there we go. Explicit is better than implicit. Okay, making something clear rather than just assuming something is there. Simple is better than complex. I think I agree definitely with that one. I much prefer simplicity to complexity. But complex is better than complicated. Interesting. And finally, readability counts. Yes, that's important, isn't it? As we're going to see, the easier it is for us to read, easier it is for us to understand. So those were some of the guiding principles. Actually published in a book, an article, The Zen of Python. Play on a Buddhist tradition, I think. Zen, the art of yoga, to get to that state of Zen. We have the Zen of Python here, as summarised in these bullet points. Yeah, so we've talked a lot about readability. Hopefully you're going to see that as we start to explore the syntax. Productivity, yeah, or in other words efficiency, it does save a lot of extra writing. I guess the same is true with just natural writing. If you're writing an email or writing a report, you don't want to repeat yourself. You want to be able to express things ideally once and build an argument as you're progressing, and just keep going back to the same point again and again and again. So the more efficient you can be, the more easier you can make it to understand and read. It's definitely going to help. Portable, that's another interesting term. So again, this is, this was certainly a bigger issue in the 90s than it is today. We have we see an awful lot of progress, don't we? Migration between operating systems. Now, a lot of apps can run on either. That's just common expectation now, isn't it? That we can have apps that run on every platform. We don't have exclusivity. We don't have those problems of migrating really from one system to another. So that's hopefully a thing of the past. So odd bugs and things here and there. I'm on a MacBook Pro M1 chip, the silicon chip, which has slight differences to the Intel. So some software doesn't always run as expected. But thankfully that's in the minority now as opposed to the majority. So anyway, that's useful for Python. We can write software that runs everywhere. It's going to save us having to write lots of different versions of it. One for Windows, one for Mac, one for Linux, one for Unix, one for your smartphone, one for your desktop, one for your laptop, one for a big screen, one for a small screen. Ideally, we can write it once and reuse it. And of course, the extensions are very helpful. So I mentioned a few of them already with NumPy, Pandas, Matplotlib. That's for data work, but equally there are lots of other libraries out there developed as part of this big community, which can just be reused and can easily be installed. So it enables you to be able to make use of stuff rather than rewriting it again. You don't have to reinvent the wheel, write something from scratch. You know, there's libraries for it elsewhere. So it's easier to download those and integrate them. Indeed, we see a few of them here in this slide. So Django and Flask, I don't know if you've heard of those, but they're big in the web development world. So it makes it easy to get up and running with web apps. NumPy, Pandas, and Matplotlib, I've mentioned those for data analysis. Raspberry Pi, I don't know if anyone's played around with that, small bit of hardware. Maybe at school you might have had some hardware on that. It runs Python, so natively. Web scraping, I don't know if you're familiar with that term, that's related to data work. So that would be actually looking at websites out there and writing algorithms that can actually just trawl through websites and extract data from them. So it means understanding all the different tags of HTML, CSS. So an algorithm which can collect all this data and then feed it into these libraries to be able to analyze them and produce analysis and visualize that. Vision, OpenCV, just an easy way to get coordinates and geometry off the ground. I've explored that in some notebooks. Had a look at that. I've mentioned machine learning as well, scikit-learn, NLTK, that's Natural Language Toolkit. Just again, libraries for natural language, how you process that. TensorFlow, that's artificial neural networks. And then Pygame as well. So that's an easy way to just develop some quite interactive, quite really good looking actually, some really useful artifacts there just for developing really interactive, engaging games in Python. So lots and lots of uses in this day and age for Python. So there we go. There's a little succinct history of Python, a little introduction to it. Let's have a look at some coding concepts now and how we would translate that into Python. So first things first, I don't know if you've done any coding before, but it's traditional, it's conventional to print hello world to the screen as a very first program. So that's exactly what we're going to do. We're going to write in Python this keyword here, print, hopefully you can kind of discern what it does from its name. It's going to print something, not physically, we're not going to have to go to a printer and get out some paper, but it's going to print this to the console, to whatever IDE that we're working in, whatever frame that we're working in. It's going to print something. And what do we have? We've got a pair of curly brackets. Does anyone want to tell me what those curly brackets are also known as in computer programming speak? We have a technical term. Does anyone remember? No. Parentheses. So they're known as parentheses, and what goes inside them is known as a parameter. A parameter. Okay, and what is this parameter? Well, it is. Anyone know what those speech marks represent? What? Ooh, okay. They're a certain type in programming. Khalifa?
Yeah.
Do you know what those speech marks represent?
Something parameter.
Parameter. Oh, well, it is a parameter. Yes, correct. It is one parameter in the parentheses being passed through the print function. I just wondered if you knew what type it was.
Oh, data type.
Yeah.
Is it integer?
Whoa. Is it integer?
No, is it a string?
It's a string, yes. So an integer, it would deal with whole numbers. We've got a section on it, so that might come back to us. Just curious if you knew it. But no, it's a string, isn't it? And the giveaway is words, letters, so characters. A string is a collection of characters. Could even be described as an array of characters. It's treated as an array in traditional languages. It's in Python as well. So it is a collection of characters, make up words, text that we can read. You can have symbols, you can have numbers in there, but it's treated as a string, whereas an integer would only deal with numbers or digits. Okay. Can an integer have decimal places though?
No.
Ooh, no, it can't. It's only whole numbers. Only whole numbers and integers. So if you try to have a decimal place, it probably, well, in traditional languages, it cuts it off. It removes the digit. Probably in Python, it would just treat it as a float. Yeah, you might have heard it as doubles or as lots of other decimal place formatting in traditional languages. But here in Python, let's just focus on this basic example. When we were to run this, this is a cell. It's kind of mimicking the Jupyter Notebooks layout. Of course, you can write Python outside of Jupyter Notebooks. It's just a very convenient way to get started. When we run that, we see hello world printed to the screen. So if you're brand new to coding, not sure where to start, that's a go-to. Just to check you can get something into the program and something out of the program. So if this was compiled and deployed somewhere, the user runs this, they're going to see something. Okay, so that's the simplest form of programming that we can get off the ground. We're just outputting something. Output to the screen, print to the screen, display, show, all those verbs, all those kind of action words to display something, to show something, to print something on the screen or on a frame is what we're going to use for output. Okay, it's typically one of the final steps. We said, didn't we, input comes generally first, and then we have some sort of processing of that input, calculations, update something, buy something, send something, remove something, and then finally an output, some sort of confirmation, or a receipt perhaps when you buy a product. You get a little email, don't you, to say that's the confirmation that you've ordered this. Okay. Let's keep going. Let's have two print statements this time. Let's put two together. So in this case, we've got hello, and then we've got another string. We've got another pair of speech marks. So,
What those numbers mean?
What do those numbers mean? In this example, nothing in particular. It's trying to resemble an 8-digit ID. So something that you might be familiar with. You have a unique ID. I use the student examples quite a lot just because it's something you can relate to. So something resembling an 8-digit ID number for a student. It's still a string though, isn't it? And notice I've got numbers in there and characters. I've got capitals and lowercase. So it's all treated as a string. We'll get into types very shortly, so I'll unpack the differences between them. But yes, we've got two here. Would these appear on the same line, or do you think they'd appear on different lines?
Different?
Different lines. Yes, in Python they are. They're displayed like this. Obviously, if you don't have any sort of print line or escape character \n in traditional languages, you probably get them appear on the same line. You have to manually state that you want a new line after you print somewhere. Okay, but in Python, it's going to think you're going to start a new line. It assumes that, so we don't need to worry about that. That's useful to know. Okay, and that's just what we get as an output there. All right, so let's move on. Let's talk a little bit about variables now. And it's a concept. It can be a little bit tricky as a concept to understand because it's an idea. It doesn't physically exist. It's not something physical I can hold or touch or see. It's not something physical. So we have to build an idea of it in our minds. Okay. So let's see if we can do that. A lot of text here. Let's see if we can unpack it. So variables, there's a number of key components with variables. I mean, first and foremost, just by the name, if something is a variable, what could you tell about it? Think of a science experiment. If you have variables in a science experiment, what could happen to them?
They could change.
They could change, exactly. Something that is variable or varies is something that could change. Yes, that's correct. It's one of our key points here. We can, I'm going to get to the storage. We can store data in the variables, and we can also overwrite that data and change it throughout the program. So the value stored there varies. Okay, that's definitely a key component to it. As opposed to, let's say, a constant, which, again, by the word implies it doesn't change. It stays constant. It stays the same. It's defined once and never changes. So constant and variable, there's two words to be familiar with. Let's talk a bit more about storage, because that's very common. We mentioned about data storage earlier to compute. You're right, if we're going to type something in on our keyboard, we don't want to just forget about it. We want to store it somewhere. So variables are a way to store that data temporarily. And we use the assignment operator. That's something we're going to be seeing. It does have the equal sign from maths, so it is different to the equal sign. So we have to remember. We're going to unpack assignment in just a bit, but it is used to store data in a memory location. Typically temporary memory. We don't need to write it to the hard drive per se, unless we're going to output or export a result of our program. But generally, it's just stored for the duration of the program, just temporarily in some memory that's allocated to the program by RAM usually. It's then flushed by the end of the lifetime. Around as we see here, and it can, we can mention that change. So there's kind of two key things to start with. That's a storage area. It's used to store values that corresponds to meaningful data, like products we're searching for, names that we're entering, like a data entry form. If you're signing up to a website, you type in your name and then your surname and then contact details, email address and all that. So it's used to store meaningful data. But then, of course, we can change it as well, so it varies. It can change throughout the program. So let's explore variables in a bit more detail. So here we see some code from the traditional languages, let's say the strongly typed languages, different to Python. So C, C++, C# and Java would tend to prefer this sort of formats, where we actually define the type first. And we spoke about type, didn't we? So remembering that in Python, we don't actually have to declare the type. In other languages, you do. So here, we're formally saying that the data going to be stored in this variable is going to be a string type. Can't store anything else in it. So string, we declare, and then that's the data type, and then second comes the variable name, or identifier. So that is...
String name?
What do you think, Khalifa?
I'm just reading it.
You're just reading it. Okay, yeah, fair enough. String name, exactly. So that's the variable. Type of data that's going to be stored, and the variable name that we can then come back to get what value? We're going to get this value. The value that we assign to that memory storage space. We're saying, using the assignment operator, that we're going to assign this value to that alias. And I use the word alias very carefully because it is actually an alias for a memory address. Okay, it's actually stored at a memory location which has typically a hexadecimal address, but rather than us having to remember all those strange and weird and wonderful combinations of letters and numbers in some random order, it's not very meaningful. Far more meaningful for us to call it something that we can relate to. So if we're typing in someone's name, let's have a variable that's called name. Okay? Yes, so these are the traditional languages. We have to say the type, the variable name, assignment operator, and the value. Let's have a look at Python. In Python, we don't need the type. We could just say variable name equals value. We still need this half. We still use the assignment operator. We still have a value, but we don't worry about the types. We could limit things to types, and indeed, libraries like NumPy are optimized to go back to defined types because there are certain advantages and disadvantages with losing types. One of the advantages, of course, with Python is that we can change the type. We can actually start this variable as a string and then later assign an integer to it. We wouldn't be able to do that in traditional languages because the memory is scoped to that type. A certain amount of memory space has been allocated for that type. Each type has different memory requirements. So we wouldn't be able to violate those rules that have been set up. But in Python, it's built differently at the back end. So they're built as just objects which descend from a higher class, let's say, and we can interchange the values that we assign there. Okay, so useful from that point of view, but of course it does have disadvantages when you get into efficiency. Indeed, something to explore later on in the module with things like NumPy, and the preference is to go back to things like traditional integer types there. So anyway, that's a final point. So we don't need to define the type. We just say variable name, assignment operator, and then value. Okay. If you're new to types, it's probably worth just being aware of the basics of them. We don't need to master them with Python, but it's useful just to know what they are in case we need to go back to them at a later stage. So int, as we established, is for whole numbers. So examples like this. If it's a signed integer, which they would be by default, you can have a minus sign. If it's an unsigned integer, it's got a u in front of it, like uint, then we can't. It actually gets rid of the sign. It has absolute values of just whole numbers, okay? And then floats in Python for decimals, okay? So if you want to store decimal values, use a floating point number, a float type. So they're generally the types. They're actually built as classes, as I said just recently. They actually inherit from a higher class, all from the same package. So that's something to come back to as well, the classes. We'll major on that right now. str, let's move on to some other ones. So int and float for your numeric types, whole numbers and floating point numbers. And then str for, we've seen it can store whole phrases, so a combination of characters. You can use both the single quotes and the double quotes for it. It can store characters. Some languages have dedicated char data types. Character, which only store one single character, but str has kind of amalgamated the two as a string. And then finally bool. I don't know if you've come across this from Foundations or not, something like George Bool, George Boolean, can be used for establishing true and false. So something to remember that in other languages, they can be written as lowercase t, true, and lowercase f, false, but in Python, they're actually built as uppercase t and uppercase f. So just be aware of that. That's one nuance with Python. Other languages let you use the integer equivalents like 0 and 1 as well. But in Python, true and false are the two established values for that data type. Okay. And if you wanted the table, here they are, as all visualized here. So integers, whole numbers, floats, decimal point, floating point numbers. You see an example there for pi. str for strings. See there, the speech marks, double quotes or single quotes, of course, it's interchangeable. We've already established uppercase T true for booleans, bool as the type. And then also we do have a capacity for a null value. So again, if you're coming from other languages, you might use null as a type. It's actually rebranded as none in Python. So uppercase N for none, as we can see. If we just want to set something to be empty or have no defined value, I mean, just be aware that if you write 0, that would be treated as an integer, or even an empty pair of speech marks, that would also be counted as a string. So none actually classifies as a completely different type, completely different value to those values. Okay, so as I say, we don't have to worry too much about this. In Python, we can get away without defining types at all. Some values we need to pay attention to, of course, but it is useful to be aware of these, especially if you move on to other languages. Okay, so some rules about variable names. As we've already said, it's useful to pick meaningful names, isn't it? It makes it easier for when you come back to try and get data from that variable. I don't know if you've ever parked your car in a big multi-storey car park and forgotten where it was. It's a bit of a nuisance, isn't it? What level did I park it on? Which section of the car park did I park it on? So it's useful to pick variable names that you can then come back to, isn't it? Okay. So if you're storing a name, a first name or something, don't call it bananas or pears or something like that. You know, call it first name or something like that. So you can actually come back to. And not just for your benefit, for other people's benefit as well. We just said about code readability. Coders often work in teams, so it's useful if you all agree on a naming convention so that you can all understand each other's code. Okay, so it's not just for your benefit, it's for other people's benefit as well. Best practice to start with variable with a letter. Some people do start with underscores in very defined places. There's actually examples of that in Python. We'll see that later on. Can I have spaces? That's something we need to pay attention to. We can't have spaces. The Python convention is to have an underscore. Some languages have camel case. I don't know if you've ever seen that or not. That's where the first letter of a new word has an uppercase letter, and then lowercase for the remainder of the word, and then a new word. First uppercase. But in Python, it's generally all lowercase with an underscore separating the two words, like first underscore name, second underscore name, surname, or last name, or something like that. Okay. We can't use reserved words that are already being used, data types, conditional statements, class names that might be already used, core of Python. And also be aware that casing will actually distinguish between variable names. So you could have variable names of the same semantic meaning. Notice here I've got uppercase name and lowercase name. So semantically they're the same word, but they are treated as different memory spaces in Python. So just be aware of that, okay? When you're using those. Okay. So useful to be. You should find those rules do apply across most other languages as well. So again, good practice to be aware of that. Let's have a look at assignment. We did have an intro to it a little while ago, but this equal sign is going to become very important because that allows us to assign values to those memory spaces. In some languages, you can actually declare the memory space, the variable, and assign later in the statement. In Python, it is convenient, obviously, to do it in the same line because we don't have the type. So it's useful to initialize the value to start with because there's nothing else, there's no type that attaches to it generally. So that's why you tend to see this all happen in the same line. One point to note as well, if you've done maths before, I'm sure you will have, is that the equal sign in maths has a very different meaning, doesn't it? Because it's generally used to balance two sides of the equation, or at least show equality between the two sides. In programming, there is a way to do that. It's a separate operator. It's actually two equal signs for equality. But one equal sign in programming means that we assign the value on the right-hand side to the left. Okay, so you're actually reading from right to left in programming, rather than left to right, which again is a difference for us to be aware of if we're new to programming. Because usually, if we're from an English-speaking background, then we would read left to right generally, but in programming it's generally right to left, it's the other way around. Okay, and I think we've got an illustration of that here. And if I show you this, this is the general format where you'd have the variable name, if this was something like name, equals, and then a defined value. That value is going to be assigned to that variable, or the alias for that memory space is what we would say technically. Okay, so that's the assignment operator. So right to left, not left to right. We're not assigning that to that, it's the other way around. It's assigning that value to that variable space. So that when we write that variable name later, we can retrieve that value. So we're essentially storing it to then retrieve it later. Okay, and there's a little example, as we've seen a few times already. Okay, so there's the data. The string value, as here, speak marks, is going to be assigned to this variable, so that when I write that variable later, I can actually get this value back. Okay, so I'll quiz you on that a little bit later, see if you've got that. Here we go, here's an example in Python. So, name equals Nick. Nice and easy. There. I could then, it's not concatenation, but it is including it within that print statement now. So I'm actually going to join those two strings, that's a string and that's a string, I'm going to join them together, but they're in, but of course Nick is in there, so I need to kind of put that in the same line.
Hello comes first, no?
Sorry?
If you put them into the Python, hello comes first, no?
Oh, yes, when we print it out, you'll see that, yes. I'm essentially attaching the value that I stored in name, I'm going to insert it into this sentence at that position. Yeah, an order doesn't matter. If I started with name and then put hello after it, let's see, Nick hello. Okay, so we can use these variables to piece together sentences. I think I've got another example. Okay, we'll come on to a bigger example. Here's another way of doing it, using the plus sign. So in mathematics, of course, you would know a plus sign from adding two numbers together. In programming languages, you actually join two pieces of data together. We've got strings here. So what do you think we're going to see on the screen here?
We're going to see hello, Nick.
We do, but we actually see...
Say how do you define space?
We haven't got a space in this instance. But if you pay attention to the layout of the previous slide, notice there, comma's quite intelligent. It knows, because it's, again, coming from traditional languages where we don't have this facility, where we generally concatenate like that, we're used to writing hard-coded spaces, white spaces, into the string, just to piece it together, make it run smoothly. But in Python, we're treated. We get the space added in, so we don't have to do that. The comma intelligently adds a space for us. So just be aware of that difference, that subtlety between those two ways of doing it for concatenation. Indeed, if you go back to other languages as well, you'll have to remember to transition back. So remember to hard code that space into there so that you can get a nice clean output. Okay, it's all part of the fun of string manipulation and changing. There's an awful lot to discuss on that. So just be aware of that. Also, in Python, we're also treated, we can actually just state the variable name itself to see the value of it. We don't need to write print, just write the variable name and it retrieves that value which was stored there. Okay, that's probably only useful in just checking circumstances. You want to check the value. If you're constructing a nice report or a print or something to print out, you probably will have to use the print method to construct it in a certain way. But just for checking values, it can be quite useful. Just write the name of the variable. That's maybe a bit more implicit than explicit. If you find it easier, something like this may be a bit clearer because it's very explicit, isn't it? Print. Print this value stored at name. So that tension between implicit and explicit. This is a shortcut, essentially, which is more implicit. You'd have to know that it will print it out. It will retrieve the value there. Okay. Or another way I like to think about it is as placeholders. A bit like variables as well, that value could vary. Indeed, if I update the name later, change it, indeed, when I refer back to it, it's going to refer to something different, isn't it? So that name is really just to be substituted with something else a bit later. Okay, that's how I sort of get my head around it. Okay, let's add in some more variables now. So we've got two. We've seen the name being assigned. Let's add in another variable. Here we go. Age is the variable name. That's going to be assigned a value. What type is that? Yes, whole number. Yeah, whole number. I haven't got the speech marks. That's a dead giveaway. Colouring as well is another giveaway if you use an intelligent IDE. So green colour associated with numbers. We'll see that. And red with strings. So yes, two different data types. That's a string and that's an integer. Put that all together into a sentence, and then you are 30. Isn't that nice? So a way to combine variables now. And notice there's no spaces in there. The commas will quite intelligently insert the spaces at the various points. So again, we're treated in Python. We'd have to put all the spaces in there, if we were using the plus sign, okay, to actually make it read nicely. So just be aware of that. This is a throwback to some traditional ways of formatting. Placeholders again. You can use these as substitutes, these keywords, D and I for integer. Unsigned integer, remember we don't have that bit allocated for the sign. That's removed. F for floating point number, different precision points of floating point number, E, capital E, exponents, we've got a whole range of precision there. Single characters, C, S for string, and then literal character as the percentage size. You could also format it like this in a throwback to more traditional ways of formatting. Okay, so lots and lots of different options to do this. Choose one that's going to be easy for you to start out, but no doubt as you progress you might get more specific in how you want to format your strings. Okay, so let's just do a little bit more on types. As you can tell, there's a lot to discuss on it, a lot to talk about. A quick note on static and dynamic. Remember I said in Python we're not scoped to a certain type. Whereas in the traditional languages, C, C++, C#, Java, we declare a variable to be a certain type. This is an integer, this is a string, this is a boolean, this is a character, a char. Okay, and we cannot deviate from that. It's statically bound, that memory location, to that type. Indeed, the back end, each type has a different memory space, so the number of bytes will be allocated for particular types. Okay, depending on their precision, floating points. Generally, the more floating points you have, the larger the integer, the larger the number, the more memory you need. So the more bytes are allocated for that. So we can't easily switch, we can't easily mix and match between different types. But Python, they're treated more as dynamic classes and objects. We established those types are classes. In traditional languages, they are not. They are primitive types, different to classes. So that's a whole other discussion to get into. To illustrate that visually, I've got here the same variable, but I'm reallocating the value for it. So age started out as an integer, but after I printed that out, I'm going to assign it a string to the same memory space. Okay, to illustrate that you can change the type dynamically. You're not limited to a certain type there. Okay. We can also use the type function to confirm that too. So here we go. We've got here class, also confirming it's a class, and it's an int, and this one is a string, the second one. Okay, just to show you can easily switch back and forth. Okay, you wouldn't have that luxury in other languages. So that's a unique feature of Python. Okay, let's talk a bit about casting. Has anyone heard of casting? Has anyone come across that term? No? Okay, all right, well let's explore it then. Consider this. Consider this. Can you foresee a problem?
Yeah.
What would that problem be, Isman?
One's a string, one's an integer.
True. And then notice here, what would be the problem in this case? What would we be attempting to do from that plus sign?
Which one is an integer?
16, yeah. We can tell it's a string by the speech marks, remember? It's a giveaway. Colouring too, okay. All right, well, let's break it down. By this plus sign, do you think we are trying to add them numerically or arithmetically, let's say, calculate?
Calculate.
You think we're trying to calculate? Yeah, okay, yeah, I would assume that's what we're trying to do, yeah. But can we add
No,
them together? Why not?
I don't think we add them together. We trying to calculate and find out what it really means.
We are trying to do that, yes, but the type is going to be the issue here. That's exactly what we are trying to do. We're trying to numerically, arithmetically, add the two numbers together. But the problem is the compiler's confused. So it's saying, hang on, you've given me an int and a string. I can't numerically add them.
Unsupported.
It's unsupported. So if you try to do that in Python, you probably get an error like this. Okay. So, whilst Python is flexible, it cannot get around this issue, where it cannot assume that's a number, because it's inferred to be a string. Okay. So, a way around this would be to cast that string to an integer. So temporarily, we're calling the int as a function, so pair of parentheses, remember? Parameter being passed to the function. Temporarily convert it to an integer and store it there. Two integers. That's better. I can add them together now. Okay, and there we go. So the compiler gets a bit confused because it doesn't know whether you're trying to add the two numbers or trying to join them. Remember all that way back we saw we could actually use the plus sign for concatenation, where we're trying to join two strings together, or a string and a number, okay? But in this case, we make it clearer if we indicate the plus sign is being used for addition. That's what I was looking for, addition. I got there in the end. Addition, rather than concatenation. I was looking for a word, I couldn't find it. There we go. We can also apply that casting principle to other things as well. Here we've got int and floats. So I started with an integer. Casting to a float, I'm going to add a decimal point there. Okay, so we started out with the same, you could call it a scalar value if you want to, or just a plain integer, a literal. Started as an integer of 30, casted it to a float temporarily, and we got 30.0 as opposed to 30. So again, precision may matter. Again, our types there, we can get to a floating point number from that. Ooh, let's give you a quiz. Okay. Consider this example. What do you think the output would be in this case?
64.
Yeah, you got it, yes! We are joining them, absolutely. So just to throw you off, I was wondering if you thought we might add them. Nope, we're going to, in this case, join them together. So remember the plus sign can also be used for concatenation as well as addition. The fancy word here for this, the technical term is overloading. We overload the functionality of the plus symbol to be able to do two different behaviours depending on the context here. Okay, so good, well done, Isman. One more. What do you think the output of this example will be? What are we doing in this case?
Would it be a syntax error?
Yes, very good, isn't it? It would be, yes, because again it's confused. It's saying, hang on, are you joining or are you adding? Which one are you trying to do? So we'd have to either be a little bit more explicit there. I suppose we could temporarily convert that to an str. We could cast it, or if we're dealing with just printing, there's a way around it using the commas. We saw the unique functionality of Python. You could actually, with Python, just put two commas there, and it will automatically interpret them as strings and construct them as a string as the output. Okay, so that's good. Well done.
But how does that work?
For the commas, yeah, it's interesting because it would just treat it as a string, essentially in converting everything by default to a string, as opposed to these where again it's dubious. It could be addition, but due to the overloading, we don't know it's all contextual, isn't it? So it's not exactly sure. I suppose some way around that, let's say you could cast it, or you could put some speech marks in there.
So the commas would.
And the next one.
Yeah. So the commas would. Did they convert that integer into a string?
Essentially, yes. By default, it's sorry, actually SDR2 there. I've just noticed. That should yes, by default, treat it as just printing this all as a string output, a bit like we saw in the previous example. And remember, it intelligently puts the space in as well, the white space. Notice how it didn't just compress them all. In this example, it would have compressed them all, wouldn't it? Even if it had a run, so it would have looked strange, even if we'd have to manually add the spaces inwards, the white spaces. But this example can tolerate the different data types. Okay, so good that we're getting our heads around this. It's good that we're getting our heads around this. Well done. Well done. So anyway, let's move on. I think it's probably our final section. Inputs. Okay, so we've looked at outputs. Easy to start with, isn't it? Just print. The good news is that input is actually quite simple in Python. It can get a lot more challenging in other languages, but again, we are gracefully given this input function, which nice and easily will return something, and actually gives us a little input box, so we can just type something in. Like in Anaconda, we'd actually get this in a little box here. It will just pause. It will wait for us to type something in. And once we type something in, type my name, that is then returned, and that's assigned to this variable. So notice here we've got the same features as what we saw before. It's essentially the same as name equals speech marks nick, like we've seen before. This nick here would replace what's going on here. So again, this can be a tricky concept to understand, the idea of using functions where you would generally write literals, but just think of this as a placeholder. This bit here is a placeholder for whatever you type in that input box. And then that is the value that's stored in the variable that can then be retrieved when we print it out. Okay, so don't be put off by that. But so technical note is that input does technically return it as a string, but remember casting, we can apply casting here as well. So we've actually put this input, which was a function, we've got the parentheses here, haven't we? Oh, by the way, that parameter as well was just the prompt, if you're wondering what that was. This won't be the input, this is going to be the prompt that precedes the input, prefixes the input. Okay, it's just prompting us. What do we want to capture? What do you want to enter? Enter the age in this case, and then because that's going to be a number. Rather than storing that as a string, as a speech marks, we're going to convert that, pass it to the int cast, which converts that and stores it in age. So that will be the converted type that we type in. Let's run it through. So here we go. We start off right to left, remember. So we're going to start with the inmost brackets. So pass this string literal to input. Okay, what does that do? That prints it out. And then it waits for us to type something in. 30. Okay, that 30 is returned and passed to int. On the outside, we started in, we're moving out, right to left. And then that 30, which was a string, is converted to an integer. And then that is stored leftmost side in age. Okay, so we've scaled up the complexity of this now. I've just added an extra step in. And then, of course, we can then use that in our print statement. Makes sense? If you step it through. If it's a bit confusing, just break it down. Start with the inmost, and then just pass it one level along each time.
It's basically going backward.
Yes, right to left rather than left to right. Yeah, because we read left to right if we're native English. Left to right in English-speaking countries. Other countries, of course, be different, and other countries do read right to left. In programming, it's definitely right to left. Okay, you just have to start at the right-hand side and work left. Okay, it's just another adjustment to make when dealing with programming. Okay. Yes, so we're coming to the end now. Let's just finish up with some comments, just style here. And comments can be useful, I should say. You might not appreciate them when you're starting out, but they certainly are very useful when it comes to industry practice. Indeed, they're actually used to build documentation. So the websites that you look at for documentation are actually built from these docstrings in Python. And these are comments that describe or summarize what a block of code does, and then that is essentially used as part of the web page, which you would look at for the documentation. So you can actually generate documentation from these comments. It's really cool. And they're also used to just test things as well. So you can actually comment things out, comment lines of code out if you don't want that line of code to run. As you see here, if I use the hash symbol on these two lines, it's actually going to sort of grey them out or use a teal colour. And then if I try to run this code, it wouldn't actually do anything. It's going to be passed by the compiler. It's going to pass over it. It's not going to run them, so we don't see anything as a result. Okay. I could do this though. I could actually use it as just a little description. I mean, hopefully, if we're coding well, we won't need to use comments on every line. That's a little bit too overkill, a bit too much. Well, most things we can tell what's going on, can't we? If we understand this is assignment, then I don't need to necessarily say that I'm declaring it and assigning values. Hopefully that can be understood. So as you get more advanced in your programming, yeah, as seen here, you can then run this. So even I've got the comment here, it allows me to run the other code. Okay, it's going to pass over this bit, and run all the rest of this code. It's only this bit that's not going to be run. It's just text here, just a little note to myself, a little note to the reader. Again, when we right at the start, we talked about readability. It can select comments can be useful if things aren't so easy to read. If you've got a confusing line, perhaps a good candidate for that comment could be something like this, where it's a little bit more confusing, isn't it? Because we started here, we passed that to there, passed that to there, and we passed that to there. So there's actually 4 different steps going on. Quite complicated. So we could write a little comment there just to say we're casting the string to an integer. Okay. So that's wise. Use them sparingly. Don't have to use them all the time, but just use them where things aren't so easy to read. Okay. Yes, and comment the code. We also have. For more larger comments, we're actually writing paragraphs or summaries of things. You'll see this in your documentation. If you ever look things up online, you see just paragraphs and paragraphs of explanation, don't you? So you can use the free speech marks, just so it doesn't treat it as 2 matching pairs of speech marks, remember? Because if you had 2, it would probably think it's a string literal. So we're actually using free pairs of speech marks, just to indicate this is a block comment. A massive paragraph, okay? And then what we can do, we can actually put that into our code, and that's then treated as a docstring comment. So that when you generate the documentation for this code class, we'll see more of that in the next lecture, that can then generate all the documentation for us. It can explain what this function is, how it works, what it does. And there's other tags as well, like author, version numbers, parameters, return values, all of that. We've got tags just to make use of it. Okay, yeah. So that's the end. A preview of what's coming up in the next instalment of our Python lectures. We've introduced the basics in this lecture. Thank you for paying attention. Next lecture, if you want to come back for some more, if you'd like some more, we'll have a look at flow. We've seen a little bit of sequence already, just the flow from top to bottom, one instruction after another. We've seen that at a very small scale. Obviously, we'll build more lines of code. Selection, though, allows you to select between blocks of code. You'll see that with things like if statements. If this condition is true, then run this block of code. Else, run another block of code. Actually, don't run it as it's written. We run it depending on whether that condition is true. And then we also have iteration, another word for repetition, to repeat something. We might want to repeat a block of code a number of times for counting or for totaling something. Okay. things like the for loop or the while loop, okay? And that's going to repeat whilst the condition is true. So a key distinction, just to give you the heads up, is that selection statements run once if the condition is true. Iteration or iterative statements run whilst the condition is true. It's just going to keep going on and on and on and on and on and on and on until that condition becomes false. Okay? So logic there. Apply all the basics of logic. If something, for how many ever times this is true, keep repeating. Keep going round and round and round and round and round. Okay? So I'll finish there. That concludes this first lecture.